Security testing. Well, over the years, there's a couple of methods that had been developed, but at the end of the day, the ambition was always to shift left and have as much as possible done during the development phase of the system. And when we talk system, we don't only say the coding part or the server setup or all these other maintenance things. It's basically end to end. So therefore, let's say if we talk about security testing, in general, you can roughly put it in three main categories. Security source code review, and the important part is here is really the security review, not just performance source code review or optimization, efficiency of code, and removing redundancies. Yes, that contributes to some extent to security as well. However, the main part is here to find security vulnerabilities that are embedded in the coding. So the scanner has to run following a certain pattern, and you have different kind of profiles that you can activate, and common ones are, of course, the OWASP top 10 findings that the source code review will look for, but you can also expand it to other vulnerabilities related to that. System scan, purposely mentioned as a system scan, not software scan, not server scan, not cloud room scan, because you have to see the whole system end to end with all its components, with all its modules, with all its deployments, be it internet facing, backend, middleware, interfaces, everything. Yeah. So scanning the whole system is important. Yes, you can do server scans, but don't forget interfaces and don't forget any other components that are maybe not represented as a server. And the classic penetration test, that is a common industry standard. Again, OWASP top 10 is the main thing to test against. Usually the test is a time box, so the penetration tester is using different tools to intrude into the system, of course listening to the traffic, and trying to make sense of the attack paths that are applicable for that particular system. And as I said, OWASP top 10 is the main thing. So finding SQL injections, of course, for example, is easier in a source code review because you will definitely find all occurrences of it. During penetration test, most of the time you just get a proof of concept where the tester says, well, I discovered one screen where this is happening, and if you fix it, please fix it thoroughly across the whole source code. So that's why sometimes penetration test is a little bit of a gamble, because let's say if the pen tester didn't have enough time and you have thousands of different sites and maybe the 250th one has that one field that is vulnerable, which is kind of strange because normally when you code, you should consider that field in the same format like the others. But yeah, it could happen like that there's one thing that he has not or she has not found, and therefore no POC was generated and you would never know. And therefore source code review is the more thorough one. Penetration test should really just be the tip of the iceberg later, or the icing on the cake, so-called, to find really other things that are not occurring so obviously from the source code point of view. OWASP top 10 already mentioned. Another good benchmark for security is the CIS benchmarks. These are profiles for servers which are hardened. So there you have the outline, what kind of configuration you should do on top of a normal standard config that comes from factory to improve the system and make it more secure. It's a little bit comparable with what you do at home, maybe when you get a Wi-Fi router. You change password, you close some ports, you register MAC addresses. Similar thing you can do on a server, and definitely much more because there's a lot of settings that you can configure. You still have CVE repositories. I mean, there's daily CVEs generated, medium, high, critical. Not everything is always applicable, and therefore it could end up being a lot to look at because these lists are usually very long, and you have to have some prioritization what to fix and how to fix. Most of the time Patching will do the trick because that usually eliminates a lot of CVEs, but of course you have to see which component is affected by which CVE, because sometimes there's no patch available for that yet. So you have to find some countermeasures and see what you can do there. So it's very good to run some scans and look for it. And one fancy tool that came out a few years ago is the cloud security posture management. There's a couple of suppliers that are offering this. This is definitely like a combination of nearly all of it in the cloud, and it even gives you a prioritization by telling you which vulnerabilities in combination with other factors are the most dangerous ones, so you can work them off and then you can work yourself deeper into it. But it definitely gives you some kind of an agenda, which is very important, because vulnerabilities, you can have enough, yeah? But how much is enough to be fixed to be secure, yeah? And how to keep up with it. So which then poses the main question: what is better, SecDevOps or DevSecOps, or even SecDevSecOps? At the end of the day, it has to work together. The person who designed the system and the guy who is operating it should figure out what is the best way of improve the posture of the system. And if there's some stuff that can be done from an architecture point of view, that's even better, because design reviews, I mean, even though I mentioned the testing before, penetration test does not really do an architectural review. Some stuff is actually built into the foundation of your system, and it will be very hard to fix if you're not rebuilding the entire system. So therefore, early stage testing on modules, components, everything that you can get into your hands is recommended. And again, once you have the findings, prioritization, it's all about what to fix first and not what to fix only. So it's only about the order of things and not the selection and making peace with the rest. Sure, you have criticality levels, high, medium, yeah. But still, some mediums in combination with other mediums also pose a high finding, which you would never really discover because the attack path is not visible to you. So therefore, again, prioritization is only what to start with. Yeah, it's not what to end with. And yeah, do not underestimate medium and low findings. And at the end of the day, it's the craftsmanship of the system design and the system build. And don't forget, even though you review a system design, maybe in a threat model or something, later when you start testing, that is where the truth comes out. This is where you can see that there's a lot of deviations from the actual design, because in the midst of building it, certain things didn't work. Then some ports had to be opened, some configuration had to be changed. So all the hardening effort and all the fixing effort and the security finding mitigation that has been done along the build, you can technically say later you have to run a full regression. Because if you don't do the full regression end to end, and you see how all the components are coming together or not coming together, you will have a tough time later fixing vulnerabilities standalone, because everything is interconnected, and you may run into the trouble that some components are totally not usable. That makes your whole system not work, and the business function will be compromised, and it's very hard to fix. So it's like a puzzle piece, but I also recommend not wait till the end and say, well, since we're still building, maybe it's too early to test this module because there will be still a lot of changes. You gotta give the developer guidance along the way. So whatever has been built, if you have already improvement points, bring them up. Yeah. Ideally, of course, they try to implement and see if it works, but keep it there for verification later. Because again, after multiple changes, reiterations, some rollbacks, you may end up looking at a totally different system what you have been starting with. So therefore, test, and keep the vulnerabilities transparent in the list, and provide good guidance how to fix and work on it, and how to avoid making new ones. Especially the coding ones can be avoided if there's a certain coding standard applied. And even the OWASP Top 10 website offers OWASP cheat sheets. The cheat sheets help you to see how coding has to be done in certain programming language, and therefore help the developer to reinforce it while continuously testing through the whole cycle.